Number 1, the line graph shows the percent of cars for sale at a used car lot on a given day by model year. For what model year is the percent of cars for sale the smallest? This is just testing your ability to read a graph. So here we have on the bottom, we have the model year, and here we have the percent of cars for sale. And they want to know when the percent of cars for sale is the smallest. So we want it to be the lowest point because it is getting smaller as it goes down. And if I look at my line graph here, this is the lowest point. And what year was that? It was 2014. So C, circle that more clearly, C is my answer. Number 2, for a particular machine that produces beads, 29 out of every 100 beads it produces have a defect. That's a bad amount. That's too big. A bead produced by the machine will be selected at random. What is the probability of selecting a bead that has a defect? So for probability on this of selecting a bead that has a defect, you're going to want to put the number of beads that have defects on top out of the total number of beads on the bottom. And they've said, and we don't have to know how many beads in total have been produced by this machine. We just know out of every 100 total beads, 29 of them have a defect. So the probability or odds of selecting a bead that has a defect is 29 out of 100. So C is my answer. Number 3, note figure not drawn to scale. I love that. Basically, don't measure this and think, oh, by measuring it, I'll find the answer. It's not going to work. We have to do the math. In the figure, line M is parallel to line N. So I'm going to make little parallel symbols, okay? And line T intersects both lines. What is the value of X? The concept is a transversal crossing a set of parallel lines. So this line L here, line T, I need to put my glasses on. Line T is our transversal. Now, there are a whole bunch of theorems and things you have to learn in geometry talking about if I have 2 parallel lines and then I have a transversal. Now, here is what you need to know about this. There's a ton of them. There's ones that will say corresponding angles are congruent. So those correspond. They will say that opposite interior angles are congruent. Opposite exterior angles are congruent. There's a whole ton of them. All of those individual theorems and statements are necessary for doing proofs in geometry. You have to know which one you're referring to and when you're doing proofs. For something like this, here's what you need to know. If I have these parallel lines, those 4 angles are all the same. And then these 4 angles are all the same. And all of those that I've drawn in orange, all of those orange angles are supplementary to all those blue angles. Supplementary meaning you add them together, they form 180 degrees, which I think you can see right here. Because see, like here, got an orange and a blue. Together, they make 180. Here, I've got an orange and a blue. Together, they make 180. And go all the way around. Orange and a blue, together they make 180. This is what you need to memorize for problems like this on the SAT. So it's been rotated. So now the parallel lines are straight up and down, and we got this transversal going, but it's the same thing. So I'm going to color these in so you can see it. So this is congruent to that, is congruent to that, is congruent to that. And then, and yeah, I'm using opposite colors, but you get the general idea, right? Yeah. There are all of my angles that are congruent. That is going to be true always for every time that you have a parallel line, set of parallel lines, I can't talk, that is crossed by a transversal. And in this case, here, as you can see, we have this obtuse angle and we have this acute angle. They are a supplementary pair. Just like over here, you know, orange and blue, the opposite ones, they're supplementary here. We got the orange and we got the blue. They are supplementary. So supplementary means they add up to 180. So this here is 33. And up here is x. So I know x plus 33 equals 180. So to solve for x, I need to do the opposite. Instead of adding 33 here, I need to subtract 33 from both sides. That will get rid of it. Then on the left, I will just have x. And on the right, I will have, why did I draw equals twice? 147. D is my answer. Number 4, what is the y-intercept of the graph shown? This is just a test that you know what y-intercept means. If I have an xy graph and I have a function going across it, it can be any function, it can be anything, it doesn't matter. The y-intercept is where it crosses the y-axis. So in this case, there's no calculation that's involved. We just have to zoom in and we say, right there, that is the point. And what are the coordinates of that point? X comes first and then y. So our x is 0. We're right here at 0. And then my y, there is 8. 0, 8. That's that point. So let's see which one is that. That is D, 0, 8. That is my y-intercept. Number 5, the total cost f of x in dollars to lease a car for 36 months from a particular car dealership is given by, and I'm going to write it over here to the side as well, f of x equals 36x plus 1,000, where x is the monthly payment in dollars. And I'm just going to make a little note of it right here. This is the monthly payment. Okay. In dollars. What is the total cost to lease a car when the monthly payment is $400? So they're telling us up here that the total cost is f of x. So it means if I plug in a number for the monthly payment and I do this math, I will get f of x, which is the total cost. All right, so they're asking that, what is the total cost? And they are giving us the monthly payment of $400. So I need to plug 400 in there. 36 times 400 plus 1,000. And now I need to do that math. And, you're welcome to use your calculator if you want. 36 times 400, 36 and 4, 72, 144, 2 zeros. All right, so 36 times 400 is 14,400. And we're adding another 1,000 to that. So my grand total would be $15,400. C is my answer. Number 6, each side of a square has a length of 45. I'm a firm believer. I always draw the shapes if they're not there. Each side has a length of 45. Okay, so I have my square and each side has a length of 45. What is the perimeter of this square? Perimeter is the length all the way around an object, all the way around a shape. Kind of view it as if this were a piece of land, you'd be asking, how much fence do I need to fence in? This is my backyard. How much fence do I need to buy? How long does that fence need to be? This is different from area. Area would be like if I had a wall, how much paint do I need to cover that wall? So this is perimeter, how much fence? So I just need to add those together, or since there are 4 of them and they're all the same, I can also just say 45 times 4, same difference either way. 45 times 4 is 180. So that is the perimeter of the square. It is 180, and they're not asking for units. Normally it would just be in feet, inches, what have you. Most likely, inches in this case, I'm guessing, for the square. But we don't have to use those. 180 is all we need. Number 7, 55 over x plus 6 equals x. What is the positive solution to the given equation? Right, so I have x's on both sides. That's no good. We need all the x's on one side. So to do that, over here I have 55 being divided by x plus 6. So I need to multiply by x plus 6, and I need to do that on both sides, We always have to do it on both sides with algebra. We have to keep things balanced because of that equal sign in the middle. Okay, so multiplying by x plus 6 cancels those out. And on the left, I just have 55. On the right-hand side, I'm going to distribute this. X times x is x squared. Let me write that in green to be consistent. And then x times positive 6 is positive 6x. This is very close to being a quadratic. Now, if I want to solve, when I say a quadratic, I mean in the standard form. Of course, it's a quadratic, right? It's got an x squared. I mean, it's very close to being a quadratic in the standard form where it equals 0. We want it to equal 0 to be able to solve it. So to get it equal to 0, I'm going to subtract 55 from both sides. And that gives me 0 equals x squared plus 6x minus 55. And now we're in the place where we can factor it, or we can use the quadratic formula. Personally, I'm a factoring girl. I always like to try factoring it first. So let's see what we have here. We have negative 55 and we have 6 in the middle. When you're factoring this kind of thing, when there is no coefficient in front of the x squared, what you're asking is what will multiply to this last term but add to the middle. So what will multiply to give me a negative 55 but will add together to get a positive 6. Now to multiply to a negative number, I need a positive and a negative. So one of these is positive and one is negative. I'm going to write all the factors of negative 55 down here. I want to write them in red to be all fancy. So it's 1 times 55. And because it's negative, I'm going to write it twice because this could be negative 1 times a positive 55 or a positive 1 times a negative 55. The only other factors that 55 has are 5 and 11. Again, because it's a negative, I'm going to write it twice because it could be negative 5 times 11 or 5 times a negative 11. Now I'm going to add each of these together. Negative 1 plus 55 is 54. That's not it. I want something that adds to 6. 1 plus a negative 55 is negative 54. Again, that's out. Negative 5 plus 11 is 6. Hey, I've got it. So 11 times a negative 5. 11 plus a negative 5. That works. Right, so now I can write my factoring. It is x plus 11 times x minus 5. Now to solve this, I want to set each of these separately equal to 0. First, x plus 11 equals 0, then x minus 5 equals 0. So over here, I need to subtract 11 from both sides to solve, and I get x equals negative 11. Over here, I need to add 5 to both sides to solve. I'm left with x equals 5. So my answer is x equals negative 11 and x equals 5. But be careful because it says what is the positive solution to that equation. So all they want is that 5. That is your answer. Number 8, an object travels at a constant speed of 12 centimeters per second. Okay, so 12 centimeters per every 1 second. At this speed, what is the time in seconds? Okay, we're trying to solve for seconds. That was a speed in seconds that it would take for the object to travel 108 centimeters. This is my preferred way of solving these. I've seen a couple different ways. You know, you do you. If there's another way you like better, go for it. Absolutely, of course. For me, when it's centimeters per second, I love setting up in a fraction because then it's a proportion and we can just cross multiply to solve for that x. So I have 12 times x, 12x, and then 1 times 108, 108. Now I'm going to divide both sides by 12. Since it's 12 times x, if I divide by x, it will get rid of it. And 108 divided by 12 is 9. So x is equal to 9. That's my answer. Number 9, data set X, 5, 9, 9, and 13. dataset Y, 5, 9, 9, 13, and 27. The lists give the values in datasets X and Y. Which statement correctly compares the mean of dataset X and the mean of dataset Y? Because they're asking us which statement of these four, we need to read them. The mean of dataset X is greater than the mean of dataset Y. The mean of dataset X is less than the mean of dataset Y. The means of dataset X and dataset Y are equal. There is not enough information to compare the means. The mean is another word for average. So averaging these numbers together. All right, dataset X is 5, 9, 9, and 13. And Y is 5, 9, 9, 13, and 27. There's two ways you can really do this. One, you don't actually have to do any math. It's more about understanding the concept of average or means on a really deep level that you can answer it without doing any math. If you don't feel as confident in that and you want to do the math, that's fine. We want you to get this answer right. So we're going to do what works best for you. Okay, so when we're looking at these two data sets, they start off exactly the same. They start off 5, 9, 9, and 13. So if this 27 were not there, their means would be the same. They would be identical, mean being the average. The average of those data sets would be the same. But you have this 27, so they're not going to be the same. So right off the bat, when it says they're equal, no. And this one's saying there's not enough information to compare the means. We can take the average of 4 numbers and 5 numbers. There's enough information. D is out. So we're just wanting to know if it's greater or less than. If X, the average, the mean of the data set of X is greater than or less than the mean of this. The only difference is this number 27. Because 27 is larger than the other largest number, 13, it is going to raise the average. Always. Higher numbers raise the average. If this was a lower number, if it was down here, if we didn't have 27, if the difference was a number 1 down here, it would lower the average. Always. Think about it like in terms of grades. And you can see, how this works. It's like, let's say if you have 2 students that, they have matching scores as it goes along. And then, okay, at this point, their grade is the same. And then there comes a test, and this person gets a 50, and this person gets a 95. What's going to happen to their grades? This person's grade, is it going to go up? No, that 50 is going to bring that average down. This 95, is that going to bring it down? No, of course not. It's going to bring it up. So even though from this point up, they were the same, this person is going to have the better grade overall because that 95 brought the average up, that 50 brought the average down. That's just the way it works. So you don't technically have to average them together, but you can. And there's nothing wrong with it if you're not feeling confident on that and you just want to average them so you get it. Totally fine. So let's average them and let's see what this is. 5, 9, 9, and 13. If we add those together, let's see, that's 18, and 18 there is 36. And since there are 4 datum in that data set, 36 divided by 4 is equal to 9. So the mean of that is 9. This one, we got 5, 9, 9, and 13. We already know that adds up to 36. And then we add 27 on it. That adds up to 63. And we have 1, 2, 3, 4, 5 datum in that data set. So I'm going to divide by 5 to get the mean. And 63 divided by 5 is 12 3/5. Yes, 12 3/5. Sorry, it's a long day. Didn't get enough sleep last night. Sorry about that. So yes, our means here are 12 3/5 and 9. So we can absolutely see that the mean of data set Y is greater than X. X is less than Y. So let's look at our options here. And these are the only 2 that are saying greater than or less than. And there it is. The mean of data set X is less than the mean of data set Y. That is my answer. Again, whichever way you choose to do it is fine. It doesn't matter. All we care about is that you get the right answer, right? Right. Moving on. Number 10. A rocket contained 467,000 kilograms of propellant before launch. Exactly 21 seconds after launch, 362,105 kilograms of this propellant remained. On average, approximately how much propellant in kilograms did the rocket burn each second after launch? Obviously, you can do this in your calculator. In fact, I'd recommend it. But I just want you to see what I'm doing, and also because I'm kind of a glutton for punishment, I am going to show this longhand. So it started with 467,000. This is how much remained, 362,000. If that is what remained, to find out how much was used, we need to subtract. And it'll tell us how much was used between when it started and then 21 seconds later. So that's our first step. So we're going to subtract this. We're going to go back and do all that lovely longhand subtraction from probably from elementary school is probably when you learned that. So here we have, there we go. There's our amount. It used 104,895 kilograms between when it launched and then 21 seconds later. And if you'll notice, they give that as an answer. They are trying to reel you in, but that's not what they asked. They did not ask how much propellant did it burn. Oh, no. It says on average, how much propellant in kilograms did it burn each second after launch? That is key. Reeling you in by putting that 104,000 as an option. But no, this was 21 seconds, and that's how much was burned in that 21 seconds. So we need to divide 21 into 104,895. A couple different ways that you can do this. You can do this longhand. You can do it with your calculator, or you can estimate it. This is one of those kind of tricks that's really good to know on the SAT, especially, look at our answers over here. Look how different they are. We've got 5,000, then up to 17,000, I'm rounding, then 40,000, then 105,000. Those are wildly different. These answers are not close at all. So if I were to round both of these and divide them, I would know which answer it was. So I'm actually going to do that. I am going to round this to 20, and I'm going to round this to 100,000. So 20 into 100,000. And again, if you want to do this in your calculator, you can. But a lot of times, if you know these little tricks and things, honestly, it can be faster to do it this way than to get out the calculator and type everything in. Hard to believe maybe, but it's true. And another little shortcut, if you're dividing something that ends in zeros into something that ends in zeros, you can drop the zeros. So there's 1 0 here. So I can drop 1 0 here and you'll get the same answer. These are the kind of little math tricks that can help you gain speed, gain time on the SAT, excuse me. So 2 into 10,000 goes 5,000 times. And look there, our answer is A, 4,995. That is right at 5,000. That is my answer. Again, if you want to put this into your calculator and get that precise 4,995 as confirmation, absolutely do that. But I just wanted to draw your attention to this fact that a lot of times those answers can help you. Those multiple choice answers, especially when they are degrees of magnitude different, just getting in the ballpark, and you can get in the ballpark pretty quickly, will get you that right answer. In this case, it is A, 4,995 kilograms of propellant burned every second. Number 11, if 4x plus 2 equals 12, what is the value of 16x plus 8? Two different ways to do this one. A lot of problems in this particular section have had two different ways to do it. Either way works. It's mostly what makes the most sense to you. We have 4x plus 2 equals 12. 16x plus 8 is what we're trying to find out. Right. So first way is sort of the traditional way, is to solve for x and then plug it into that second equation. 4x plus 2 equals 12. To solve that, we need to undo what's been done to x. Start by subtracting this 2. That's out by itself because we are adding the 2. The opposite is to subtract it. I'm left with 4x on the left and 12 minus 2, or 10, on the right. Then I need to undo that multiplying by 4, so I need to divide by 4. And I get that, boop, I'll move that up. X is equal to 10 divided by 4 is 2.5, or 2.5. So then I have my 16x plus 8, and I can plug 2.5 into there for x. So that becomes 16 times 2.5 plus 8. 16 times 2.5 is 40. And 40 plus 8 is equal to 48, which would make B my answer. Now, there is a method that's actually, I think, a little quicker than that. But you kind of have to have this, oh, eureka moment. And again, if you don't, it's not a big deal. It's not a problem. You can still do it the way I just showed you. But the little eureka moment is this. We have 4x plus 2 equals 12, and then we have 16x plus 8 equals, and they want to know, how do you get from 4x to 16x? You multiply by 4. How do you get from 2 to 8? You multiply by 4. How would I get from 12 to this answer? I multiply by 4. 48. That is a little shortcut because, you can change 4x plus 2 equals 12 into this by multiplying the whole thing by 4. That's the principle that's happening here. So again, also, same answer, B, 48. Both methods are perfectly fine. 12, an object is kicked from a platform. What object? What platform? Why? Why is this person kicking things? Who knows? But someone is up here and they are kicking. So something is kicked from a platform. Whee! There it goes. The equation h equals negative 4.9t squared plus 7t plus 9 represents the situation where h is the height of the object above the ground in meters t seconds after it is kicked. Okay, so I'm going to stop there for just a second. So t is our seconds. So that means if I want to know 1 second after it was kicked, how high was it? I would plug in 1 for t, because it's how many seconds. I would do all of this math, and I would get the height of how high it was. If it was 2 seconds after it was launched, I would plug in a 2, wherever there's a t. Do all that math, and I would get the height. Okay. Now here's our question. What are they asking us? Which number represents the height in meters from which the object was kicked? So here it was sitting before it was kicked. Well, what's my t? If I'm going to solve for the height, I need to know my t. It's before it was kicked. It hasn't traveled at all. 0 seconds have passed. We need to plug in 0 for t. If I plug in a 0 here for t, it's going to cancel that out because 0 squared is 0. And negative 4.9 times 0 is just 0. That one's gone. 7 times t, 7 times 0, 0. That one's gone. All that's left is my 9. The height is 9. It was kicked from a platform 9 meters tall. D is my answer. 13. F of x equals 4x squared minus 50x plus 126. The given equation defines the function f. For what value of x does f of x reach its minimum? This looks a lot harder than it is. Your first instinct might be like, okay, do I need to factor this? Do I need to solve for x? Nope. Do I need to find the zeros? No. Here is what you need. All you need is the vertex. Actually, you need less than that because they're asking only for the x value for this. So a parabola, which an x squared is here, so this is a parabola, and it is a positive here, positive 4. This means this is a parabola that is opening up. Don't know exactly where it is yet, but this is what we're dealing with. So where does it reach its minimum? It's going to reach its minimum right here at the vertex. To find the vertex, the best way is to find the axis of symmetry. That goes right through that. And and that's going to be x equals. Vertical lines are always in the formula format x equals something, just a number in this case. So x equals, and that's going to be my axis of symmetry. Once you get that, because it goes through the vertex, you have your x value for that vertex. And then you just have to plug it in there to get the y value, and then you have your vertex. But you don't even need to go that far because all they want is the value of x. They don't want the full coordinates of the minimum point. They only want the x. So all you need to do is find out what this axis of symmetry is. That gives you your x. And fortunately for you, the formula for the axis of symmetry is really simple. The hardest part is just remembering what this is. That's it. But the math is not hard. Just remembering the process is what you got to do. So negative b over 2a. When you have a quadratic, this is what we're talking about when we say a and b. Ax squared plus bx plus c. A is the coefficient of the x squared. B is the coefficient of the x, and c is the one that's by itself without any variables. So here, negative 50 is my b. So for the top, I want the opposite of that. So a positive 50. And then 2 times a. My a is this number in front of the x squared, which is 4. 50 over 2 times 4, which is 8. 50 divided by 8 is 6 1/4, or 6.25. And that's it. This axis of symmetry is x equals 6 1/4, or 6.25. And since that goes through the vertex, the x of the vertex is also going to be 6 1/4, or 6.25. That's it. Number 14. A small business owner budgets $2,200 to purchase candles. Whoa. The owner must purchase a minimum of 200 candles to maintain the discounted pricing. If the owner pays $4.90 per candle to purchase small candles and $11.60 per candle to purchase large candles, what is the maximum number of large candles the owner can purchase to stay within the budget and maintain the discounted pricing? This is a Desmos problem, let me tell you. A lot of these problems, I'm going to say you can do it by hand or you can do it on the calculator. And a lot of times, if you practiced a lot, if you really know these concepts, doing it by hand, I know it sounds crazy, it's going to be quicker. A lot of times it is. This one, no. Desmos is your friend. The only kind of the hard part of this is going to be before you go over to Desmos. You're going to need to make sure that you have the correct equations. And this is a system of equations. So, all right, let's go through this again step by step. So he has $2,200. That's the most he can spend. He has a budget. So whatever he's doing has to be less than or equal to that. He can't go over it. So something is going to be less than or equal to $2,200. He must purchase a minimum of 200 candles. So something is going to have to be equal to 200 candles, but that's the least it can be. So it may be equal to that, but it also could be greater than. All right, with me so far? All right, now let's figure out what's going to go next to these. If the owner pays, all right, pays, we're talking about money. This $2,200 was money, so this $490 is going to be going up here with the money. If the owner pays $490 per candle to purchase small candles, all right, $490 per candle to purchase small candles, and $11.60 per candle to purchase large candles. I'm running out of room. All right. What is the maximum number of large candles the owner can purchase to stay within the budget? Okay, as you notice, I haven't written down anything there yet. It is not explicitly said in this problem. We have to come up with this. What does this 200 represent? It represents the minimum number of candles he has to purchase. He is buying small and large candles. So the small and large candles together must be greater than or equal to 200. So S plus L must be greater than or equal to 200. Now I used S and L because small and large candles, but if we're going over to Desmos, I'm going to say that X represents the small candles and Y represents the large candles. Okay, so that's what I'm going to do. I'm going to replace these S's and L's with x's and y's. Now, this is the point you need to go over to Desmos. You have your two equations, 490x, and that is a 4, not a 9. Let me make that really clear. 490x plus 1160y has to be less than or equal to 2200, and x plus y has to be greater than or equal to 2200. All right, so then you've got your two equations. You're going to go over to Desmos. You're going to very carefully put them in. Make sure you get those less than or equal to, greater than or equal to symbols all correct. And you're going to end up with something that looks, I'm really not drawing this to scale, kind of like that. And there's going to be shading, and you're going to have, it's going to be shaded right there and shaded like that. Okay. That's what you're going to get as your output. And then it says, what is the maximum number of large candles the owner can purchase to stay within it? You are going to look at this point of intersection right there. That is what you want. So you're going to zoom in, you're going to get that point of intersection. And that point of intersection, if you do that on Desmos, is 17.91 and 182.09. Now we said the Y is our large candles. So the Y is 182.09. Can I have 0.09 of a candle? Well, you could carve off a piece of the candle, but if you're at a store, you cannot buy 9/100ths of a candle. You have to buy a whole candle. So 182 is going to be the maximum of large candles that he can buy to stay within that pricing. And that's going to be our answer. Yeah, Desmos problem all the way, 100%. I would not try to do this any other way. Number 15, in the linear function f of 0 equals 8 and f of 1 equals 12. Which equation defines f? Okay, when you have a function, you say f of 0, it means you're plugging 0 in for x, you do the math, and then you get 8 as a result. Plug 1 in for x, do the math, get 12 as a result. So we are going to test each of these and see which of these makes that true. I'm going to start with 0. I'm going to plug 0 in to each of these where there's an x, do the math, and see if I get 8. Wow, my handwriting is getting so bad. I'm ashamed. All right, let's plug 0 in. For our first one, 12 times 0 is 0 plus 8 equals 8. Yay, there's a contender. Plug in 0 for x. 4 times 0 is 0. Well, that does not give us 8. That one's out. Next one, 4 times 0 is 0 plus 12 is 12. Nope, that one's out. Last one, 4 times 0 is 0 plus 8 is 8. That is still an option. So then we go to our second part. F of 1 equals 12. If I plug 1 in, do I get 12? So here, 12 times 1 is 12 plus 8 is 20. Nope, that's out. This one better work, but let's double check it. 4 times 1 is 4 plus 8 is 12. Yep, there we go. Confirmed. D is our answer. Number 16. The function f of w equals 6w squared gives the area of a rectangle. I'm going to go ahead and draw my rectangle. In square feet, if its width is w and its length is 6 times its width. I think I drew it rotated wrong, but that's fine. So the width is w and the length is 6 times the width, 6w. Which of the following is the best interpretation of f of 14 equals 1,176? So we're told up here it's f of w. W is the width. So f of 14 would mean 14 is the width. All right, so before I even look at the answers, that's what I'm saying. I'm saying, okay, so in this case, 14 is the width. And I'm told that it says this gives the area. If I plug this in, then it, the function is telling me the area. Okay, so f of w equals the area. So f of 14 equals 1,176. 1,176 must be the area. Okay, now let me look at my options and see which of those matches that. A, if the width of the rectangle is 14 feet, then the area of the rectangle is 1,176. Hey, right off the bat, That looks correct, but let's check the others just to be sure. If the width of the rectangle is 14 feet, then the length of the triangle is 1,176. No, that's crazy. 14 times 6 is not 1,176 at all. It is 84. C, if the width of the triangle is 1,176 feet, then the length is 14. No, if the width is 1,176, multiply that by 6 to get 14. No, of course not. D, if the width of the rectangle is 1,176, then the area is 14 feet. Wow. So if this width was 1,176 feet long, the area would be 14 feet squared. Absolutely not. A is our only one that is correct. A is our answer. 17. Note, figure not drawn to scale. It means we can't measure it and try to figure it out that way. We have to do the math. The circle shown has center 0, circumference of 144 pi, okay, and diameters PR and QS. Okay, so they're telling us these are straight lines and they're going through the center. That's good. The length of arc PS is twice the length of arc PQ. I'm going to put some variables in here. So if I call PQ X, I know that PS is twice that long. It is 2x. What is the length of arc QR? This one, how long is it? Okay. When I have intersecting lines, that means the angles are the same. That is vertical angles or opposite angles theorem. I've heard it both things. What that also means, there's also a related one that says we have a central angle here, that the central angle and the arc are the same degree measure. So if this arc were 40 degrees, then this angle would be 40 degrees and vice versa. Okay, with those two facts in mind, this angle is the same as that angle, and this angle is the same as this arc, then we can translate and say this arc is the same as that arc. So with me on that? Because let's put some numbers in here. If this was 40 degrees, that would be 40 degrees. Those angles are the same, so that would be 40 degrees. This is a central angle, so that arc would also be 40 degrees. Okay, that's just putting some real numbers in there. Let's just put it, okay, so that's X. That means that's also X. That same principle, that same little kind of logic, almost like a little geometry proof there on the fly, was also going to hold true for these two. These are also vertical angles. This 2x, if I view that as like a degree measure, then this would also be 2x. These would be the same, so that would be 2x. And that's a central angle going to that arc, so that's also 2x. Okay, now circumference is the distance all the way around. So x plus 2x plus x plus 2x is going to equal that circumference. So let's write that out. X plus 2x plus x plus 2x, forgot my plus, equals the circumference, which we were told is 144 pi. So if I add those together, that is 6x is equal to 144 pi. To solve for x, I need to undo this by that multiplying by 6 by dividing by 6. I'm going to divide both sides by 6, and I get x is equal to 24 pi. Now they want to know what is the length of arc QR, and I've said QR is 2 times x. So I'm going to take that x and I'm going to multiply it by 2. 24 pi times 2 is 48 pi. B is my answer. 18. A company that provides whale watching tours takes groups of 21 people at a time. The company's revenue is $80 per adult and $60 per child. If the company's revenue for one group consisting of adults and children was $1,440, how many people in the group were children? This is similar to that the previous one where it's talking about small and large. What was it? The guy was manufacturing. I've already forgotten. It's already left my brain. That was number 14. Yes, small and large candles. That was it. The same kind of thing. We're going to set up two equations, and then it's a system of equations, and we're going to solve it. This one is not less than or greater than, though. It's going to be equal, so it's a little different. The same principle. We're going to read this, break it down, and make two equations out of it. Okay, we know there are adults and children, so I'm going to use A and C as my two variables. The group is 21 people at a time, so I know the total, if I add adults and children together, is going to be 21. I don't know how many of each, but together it's 21. Now it's $80 per adult and $60 per child. And they said that together their revenue was $1,440. So when they added all that up, they got $1,440. How many people in the group were children? Okay, so I'm wanting to solve for C. Systems of equations, you can solve for both. And most of the time, that's what we are doing. Usually they'll be presented in terms of X and Y, and they want you to solve for X and solve for Y. But this one just is a little time saving. If you can go straight to solving for C and don't worry about solving A, it just saves that little bit of extra time. So I am going to solve for C by eliminating A. I'm going to use elimination. You can also use substitution. That's definitely a viable way to do it because you solve for either A or C and then plug it in down in there. I have videos on substitution. I will link them below. I'm not going to go through all that. I'm going to do the elimination for this one, but absolutely, you can definitely do substitution. I will put links down below on how to do that. Okay, the calculator is going to come in handy on this one. So to eliminate the A, I want it to cancel out. So I want to multiply by something. So when I add these together, because I'm going to add these equations together, I'm going to multiply A by something, then we'll get it to cancel out with 80A. I'm going to multiply everything up here on top by negative 80. Okay, so what happens when we do that? And I am going to write it down here, down below. So when I multiply all of this by a negative 80, I get negative 80 times A is negative 80A. Negative 80 times C is negative 80C. And negative 80 times 21. Oh, is that 1,680? Negative 1,680? Let me check my notes. Let me see if I did that in my head right. Why, yes, I did. I'm weirdly proud of myself for that. So negative 1,680. Now we're going to add all these together. 80A and negative 80A cancels out. That's gone. 60C and negative 80C added together is negative 20C. And if you're asking, wait a minute, you can't have negative children, it'll all work out in the end, I promise. 1,440 and negative 1,680 gives me a negative 240. Negative and a negative. That's where it's going to fix itself. So to solve for C, since it's negative 20 times C, I need to divide both sides by negative 20. And I get that C is equal to 12. So there were 12 children in that group. C is my answer. See, we didn't even have to solve for the number of adults. And I didn't when I was prepping for this. But I suspect and look up there. Oh, yep, sure enough, if there's 12 children, then there would have been 9 adults. And look, there's number 9 at B. They're trying to get you. No, don't find the adults. Find the children. C, 12. Number 19. The function h is defined by h of x equals 4x plus 28. The graph of y equals h of x in the xy plane has an x-intercept at a0 and a y-intercept at 0b, where a and b are constants. What is the value of a plus b? They love their verbiage, don't they? And we've got some verbiage here. So we have, why isn't my stylus working? There we go. This first part right here, that the function h is defined by h of x equals 4x plus 28 and the graph of y equals h of x. All that means, all that's saying is, we start with h of x equals 4x plus 28, and they're saying y equals h of x just means you can, since this is h of x and this is h of x and y is the same, you can put y in for h of x. Why they do that? That's it. This literally, the first line could have been y equals 4x plus 28. Add the x and y intercepts together. That's what this problem is. They love putting in extra words that are frankly unnecessary. It is part of the testing process. It is a test to see if you can get through their word mess. So we have y equals 4x plus 28. This is a line. This is just a line. It's already in y equals mx plus b format. So when we have that mx plus b, I'm going to make this a darker highlighter. There we go. That's our m. That's our b. Y equals mx plus b. M is our slope. And our b over here is the y-intercept. Ta-da! So what are they asking for? They're telling us it has an x-intercept of a0, a is a number, and a y-intercept at 0, b. All right? So first thing, we need to find the x and y-intercept. Well, hey, they've given it to us in a format where the y-intercept is already there. 28 is our y-intercept. So the y-intercept is 0, 28. Because of how the graph is, the y-intercept is somewhere up here. That x is always 0 at the y-intercept. All right, so that's the first part done. Now we need to know what the x-intercept is. Well, to find the x-intercept of something, it's where that line or function or whatever crosses the x-axis. What's true at that point? What is the y value? Anywhere on here, anywhere that it crosses the x-axis, y is 0. So to find the x-intercept, you're going to plug in a 0 for y and then solve for x. So let me erase that little slope and y-intercept bit. Okay, so I'm going to plug a 0 in for y, since at the x-intercept y is 0. And now I am going to, there we go, solve for x. First, I'm going to get rid of that 28 by subtracting 28, doing the opposite of adding on both sides. So I have a negative 28 on the left. Those 28s cancel out on the right, just leaving me 4x. This is 4 times x. So to undo that, I need to do the opposite. Divide both sides by 4. And I get just that x on the left. And negative 28 divided by 4 is negative 7. So my x-intercept is negative 7, 0. Now we've done that second part of that problem. We found the x-intercept and we found the y-intercept. Now they've told us that for the x-intercept, this is representing a 0. And for the y-intercept, this is b. So we've solved for a and b. A is negative 7, b is 28. And our final question is, what is the value of a plus b? So we need to add those together. Negative 7 plus 28 equals 21. A is my answer. And you see they've got a 28 in there. They're trying to be sneaky. And once you get that 28, be like, I've got my answer. No. You have to find A and B, add them to get 21, which is A. Number 20. One of the factors of 2x cubed plus 42x squared plus 208x is x plus b, where b is a positive constant. What is the smallest possible value of b? So factoring. We need to factor this. It's completely. That's where we have to start. So 2x cubed, because it's saying one of the factors is, well, we don't know what any of the factors are. So we need to get to factoring. Anytime I see a coefficient up here in front, first thing I want to do is see, can I divide that coefficient out? Can I make this easier to factor? I also want to look at my variables. And I wrote an x cubed there, and that should have been an x squared. Come on, eraser, there we go. Squared, sorry about that. Okay, and so our variables, they all have a variable. It matches. I can take that variable out. So we're trying to find that greatest common factor. I'm going to do the numbers first. For 2, 42, and 208, 2 goes into all of those. So I can bring a 2 out. And that will leave on the inside a 1, or an invisible 1. 42 divided by 2 is 21. 208 divided by 2 is 104. Then x cubed, x squared, and x. The largest x with an exponent exponential, I'm blanking on it. The largest multiple, there we go, the largest multiple of x. I was blanking on that term. That will go into this is just an x. Little side fact, it's always going to be the one with the smallest exponent. If the smallest had been an x squared would be what came out. Like if this was x to the fourth, x cubed, x squared, and x squared would have come out. It's always the smallest one. All right, so 2x comes out, and it leaves behind an x squared here. Make sure that's our positive there. An x here, and then nothing on the end. Okay, and I don't really need that invisible one. I'm going to remove it. Okay, so I've got 2x times x squared plus 21x plus 104. Now, they are not looking for this 2x because they're saying one of the factors is x plus b. That means we have to factor that quadratic. Okay, so to factor a quadratic, now we do not have, there we go, we don't have a coefficient in front of the x. That makes things a little easier. We don't have to worry about that. We just need to look at these two numbers. And always when you're factoring a quadratic where 1 is our first coefficient, we want to know what will multiply to get that last number, in this case a positive 104, and what those same two numbers need to add to get that middle number here, a positive 21. Make sure you pay attention to those signs, positive and negative. They do come with the numbers. They attach to them. All right, so first I want to find those factors of 104. This one, it's going to have a lot of factors. It's a little bit tedious. That's what factoring is. Okay, so we have 1 times 104. And if you added those together, it would get you 105. That's not it. Then 2 times, let's see, 52. Add those together would give me 54. That's not it. Then 4 times 26. Add those together. That's 30. That's not it, but we're getting closer. Those numbers that we're adding to are getting smaller. Side note, if you need help with the factoring and finding all the factors of these, especially the larger numbers, I'm going to put links down below to various videos that are connected to the ones in this section. So I will put one on factor trees and finding factors down there if you need additional help with this. All right, so again, 4 times 26, and then add those together, get 30. The next one would be 8 times 13, and hey, add those together. Yes, that is 21. If you're wanting to know my personal method for this kind of thing, because 104 isn't, I mean, how many of us know 4 times 26 off the top of our head? Just if they said 104, what goes into it? 4 times 26, 8 times 13. Tell you what I'm doing in my head as I do this. I look and I say that's an even number, so I know a 2 comes out of it. Then I divide it by 2. That gives me 52. 52 is also an even number. 2 comes out of it. I multiply that by this 2. That gives me 4. And then I divide by 2 there to get me 26. Does that make sense? I'm taking that 2 out. I'm dividing it out of that 52 and then multiplying it by that. That gives me the 4. Dividing it gives me the 26. Okay. This one also is an even number. So I'm dividing it in my head, go, 2 times 13. So I'm going to divide that by 2 to get that, and then multiply this 4 by 2 to get the 8. That's my process for finding these for the larger numbers. Also, factor trees are great too. It's just whatever works best for you. There's a lot of ways to do this. A lot of times in math class, your teacher might go like, this is the way to do it. That's not usually true. Many times there's more than one way to do something. So yeah, that's the good thing about knowing the what's going on behind the scenes in math problems. Right. 8 times 13 is 21. So we have that 8 times 13 and 8 plus 13. Yay! Those are my 2 factors. They gave us a big one to factor, didn't they? So all right, now I have 2x times x plus 8 times x plus 13. And now we can answer their question of, x plus b, where b is a positive constant. What is the smallest possible value of b? Where there's 2 possible values of b could be 8, it could be 13. They want the smallest one. So that would be, of course, 8. Another thing you can do with graphing, just be careful with this. If you decide to go the graphing route, You can graph this. You can put this 2x cubed plus 42x squared plus 208x. You can put this into a graph and you can look and see where it crosses the x-axis. And that's where, you're going to find your factors. But please be careful with that. Make sure you fully understand what happens, what's going on there, because it's going to be the opposite. What I mean by that is this particular graph right here is going to cross at -8 and -13, not +8 or +13. So if someone just defaults to going to their graph and go like, I'm going to graph and find it that way, that's going to be super easy. But you don't realize that, okay, to find those, that x-intercept, where it crosses those zeros, I should say the zeros of the function of the quadratic, that you have to take that x plus 8 and then you set it equal to 0 and then you solve and you find that x is -8. So it's going to be a -8 on that graph. Because if you just go straight there to a -8 and then you're going to get -8 and -13 and like, wait, it says b is a positive constant. What's going on? We don't want that to happen. So graphing absolutely is a way to go for this. For some students, it's going to be the easier way to go. Just be absolutely sure you understand the relationship between the graph and these factors, or you're going to get it wrong. Just saying, graphing is a great tool, but we really need to know what's happening in the graph for it to work properly for us. Number 21, y equals -1.5 and y equals x squared plus 8x plus a. In the given system of equations, a is a positive constant. The system has exactly one distinct real solution. What is the value of a? Okay, so a system of equations. When they were asking about a system of equations, the solution to a system of equations in graphing terms is where, why is my stylus not working? There we go, is where these two things meet. Like, for example, it could be like this. Okay, these are the solutions to that system of equations in graphing terms. It's a line, then it's just one. Okay, if you have two lines intersect at a point, that's one solution. Here we have a line and we have a quadratic or a parabola. So the line is y equals -1.5. That is a horizontal line. And then we have this parabola. Don't know where it is yet, but we know it's opening up because it is a positive x squared. So we know it's opening up like that. And it's saying that this system with these two things has one solution. Now, if I draw a parabola here and I have like a straight line, and I have a straight line, if I start moving that straight line up and down, do you see how there's going to be two solutions all the way around here? Two, every single one of these points. As I go up and down, there's two solutions. So where would it only be one solution? That would be boop, right there, just where it just touches the vertex. Okay, so that's our, we need to find that vertex. That's part of it. Because they're asking for A, right? They're asking for this and this, and they say there's one point where they cross. What is A? So what they're saying is we need to find a number that goes here so that the vertex of this parabola has a y coordinate of -1.5. Whatever this vertex is, we don't know what the x is going to be, but it needs to have -1.5, and we need to find the number that will go in there to make that true. Okay. Now, to find the axis of symmetry is a line that goes right down the middle of a parabola, and that divides it into two symmetrical parts. It always goes through the vertex. That's why it's so important for finding the vertex. The formula for this is x equals -b over 2a. Now, that's really helpful here because that a and that b, I'm going to zoom in, really zoom in close so you can see this. Those are not talking about this letter A. I love how they use A in there when they know you're going to be using A for something else. This A is referring to the number or coefficient of the first term, that x squared. This B is referring to the number, the coefficient of the x term, the middle one here. Okay. So at the vertex, the x coordinate of that vertex is going to be negative b over 2a. So that b, again, we said is that 8 in the middle. So negative b, or the opposite of that b, would be negative 8. The a is that invisible number 1 in front of that x squared. So 2 times that a, 2 times 1. 2 times 1 is 2. So negative 8 over 2. Negative 8 divided by 2 is negative 4. So x equals negative 4. Well, hey, we now know our vertex, right? Because we said we knew that the y needed to be negative 1.5, but we didn't know the x. Well, now we do. It's negative 4 and negative 1.5. That is the vertex for this parabola if it's going to have one solution with the line y equals negative 1.5. Okay, so now we have this equation, y equals x squared plus 8x plus a. And we need to solve for a. Well, I've got 3 variables. I've got x's, I've got y's, I've got an a. How do I solve? Hey, I have an x and a y. I can plug in for these x's and y's, and then I can solve for a. So let's do that. First, this y, I'm going to erase it and replace it with that negative 1.5, the y from that vertex. And then for the x's, we have that x squared. Let's replace that with negative 4 squared, that x there. Then that 8x. Boop. So 8 times negative 4. I'm really crowding it in there. And the a just stands alone. Okay, so now I have negative 1.5 equals negative 4 squared is 16. 8 times negative 4 is negative 32 plus a. 16 plus negative 32 is negative 16. So I have negative 1.5 equals negative 16 plus a. And then scoot up again. To get rid of that 16, negative 16, I'm going to add 16 to both sides. So on the left, I have 14.5 and a is on the right. So 14.5 is my a. That's the answer. So again, 14.5 equals a. So again, the reason why this works is because for it to intersect at one point, it has to intersect at the vertex. That has to be true. So we find the vertex by first finding the axis of symmetry, negative b over 2a, and that gives us our x value for it. And we know that the y, for it to be this vertex that intersects with this line, has to be negative 1.5. Then to solve for that a, we plug both of those in and solve for a. Not the kind of problem you're normally going to find in your math book, but here we are. Number 22, f of x equals x plus 6 times x plus 5 times x minus 4. The function f is given. Which table of values represents y equals f of x minus 3? So this f of x minus 3 means you're going to define the y is if you're given a value for x, you would first take it and plug it in to all 3 of these. You get an answer. So that's your f of x, your answer. You take that answer and put it into here. You subtract 3 more, again, essentially from that answer, and that gives you your final y. So that's what these tables did. Each one of these tables, they took these first 3, they plugged them in, then subtracted 3, and they got a y. And so they're asking you which one of these is correct for this. Whoops, I backed up too far. Let me erase that. There we go. Which one of these 3 tables is correct and shows, hey, we took these 3 and we plugged it in. Now, there's a couple ways. There's a trick for this particular problem I'm going to show you, and then there's sort of a general, if they give you something similar to this, that I'm going to show you, because 2 different things. One is problem specific. So for the general, for this, if you were given a problem like this on the SAT, you're going to look first. They all have the same x's, negative 6, negative 5, negative 6, negative 5, 4, negative 6, negative 5, 4. Okay, they're all the same. But the y outputs are all different. You're going to look for a number where the y is different for each table. And here's what I mean by this. For negative 6, output of negative 9. Negative 6, output negative 3. Negative 6, output negative 3. Negative 6, output 3. If I plug negative 6 up here and get a number, it's not necessarily going to give me my final answer because these both have negative 3. I would have to test another number, either negative 5 or 4, all the way down. It's the SAT. We want to save as much time as possible. So first, you're going to look to the next one, -5. Okay, -5, we have a -8, -3, -2, and +3. They're all different. So if I plug -5 up here, whatever answer I get is going to tell me which answer it is. I do not have to plug in -6 and -5 and 4 because they all, for -5, have different ones. Coincidentally, for 4, also for the 4, we've got a 1, -3, 7, and 3. They're all different. So I could plug in either -5 or +4, and I would get the right answer. That's the general way you're going to do this. You would pick that number, so either -5 or 4, whichever one you prefer, doesn't matter. You would plug it in up here, do this math, then whatever you get, you plug in there, which just means take that number and subtract 3. And then your final solution, you would see which of the tables has that solution. That's the method. There is an extra little trick for this particular one. If you look at it, you might go, oh, and have a little eureka moment. Look up here. We've got x plus 6 times x plus 5 times x minus 4. And they're asking to plug in -6 or -5 or -4. I'm sorry, excuse me, +4. That makes a huge difference here. What would happen up here if I plugged in -6? Right off the bat, right here, x plus 6. If x is -6, that is 0. It doesn't matter what else if I plug in -6 for either of these two. It doesn't matter. A 0 is here. I multiply these together. I'm going to get 0. 0 minus 3 is -3. And I didn't write my negative. -3. What's true of? -5. If I take -5 and I plug it in here, -5 plus 5 is 0. I have to plug it in all 3 places, but it doesn't matter because this is 0. Multiply those together, I get 0. Plug it in here. 0 minus 3 is, you guessed it, -3. And you'll never guess what will happen if I take a 4 and put the 4 in here. 4 minus 4 is 0. Doesn't matter where I get when I plug 4 into these others because 0 is right there. Multiply them together, I get 0. Plug it in here. 0 minus 3 is -3. So yeah, you're going to get -3 for all 3 of them. You don't really have to do a whole lot of math because you don't have to plug in the -6 into each of these and then multiply together and do some lengthy thing because you're just like, oh, I keep backing up too far. Sorry about that. It's just like, no, it's just -3, always -3. And which one of these shows -3 is the answer for each one? B. Again, that is a solution, a way of looking at it that's unique to this problem. I would not expect it. There we go. I would not expect it to be this way for all similar problems on the SAT. So that's just if you happen to notice that and go, wait a minute, -6, -5, and 4. If I plug this in, it's going to get 0, -3 every time. Woohoo. Yeah. For this problem, that would work. For all other problems, use that first method that I showed you. Look through your options to see which number can I plug in where I will immediately know the answer and I will not have to do any more math. We want to be speedy. Time is of the essence. That's the fastest way. Okay, 23. For the function q, the value of q of x decreases by 45% for every increase in the value of x by 1. If q of 0 equals 14, which equation defines q? All right, so first off, before you're even looking at this up here, this is another one where you can do it a couple different ways. You can start by just trying to come up with an equation for that, or you can start by seeing if you can eliminate any answers given this fact that q of 0 equals 14. I'm going to start with that. Let's get some answers out of the way. Again, this is in the interest of time. SAT is all about time and getting things done quickly, not wasting any time so that you can finish and get your maximum points. Q of 0 equals 14. So I need to plug 0 in for x in each of these equations. I'm going to zoom in and see if I get 14. All right, if I plug in 0 here for x, I get 14 to the power of 0 is 1. 1 times 0.55 is 0.55. It says I should get 14. A is out. Next one, 14 to the power of 0 is 1. 1 times 1.45 is 1.45. That is not 14. B is out. 0.55 to the power of 0 is 1. 1 times 14 is 14. That's a possibility. Same thing is going to happen here. 1.45 to the power of 0 is 1. 14 times 1 is 14. Okay, so already I've eliminated the first two. I am down to C and D. Now let's look at that first part. For the function Q, the value decreases by 45% for every increase in the value of x. Every time this exponent goes up, so we're multiplying by one more of them. So if this was 1, it means I'm multiplying 14 by 0.55 one time. If it was 2, that means I'm multiplying it by 0.55 two times, and so on. Same down here. If x is 1, that means I'm multiplying 14 by 1.45 one time. If it's 2, I'm multiplying it by 1.45 two times. And it's saying that every time I'm increasing that, 1, 2, 3, that this value, this output that I get after I do that math is decreasing by 45%. Which of these two numbers, if I multiply 14 by it, will decrease it by 45%? This right here, this is less than 1. If you're multiplying by a number less than 1, it will decrease it. This is multiplying by a number greater than 1. Multiply by a number greater than 1, it's increasing it. So just that fact right there, without even looking to see if these numbers are accurate, D is already out. D is not possible. If they were both less than 1, then it would be a legitimate choice where you would need to look at these numbers. In this case, to decrease by 45%, because you start with 100%, and if you decrease by 45%, that is 55%. So you'd multiply by 55% or 0.55. This option D is starting at 100% and increasing by 45%, which gives 145% or 1.45. So one is increasing by 45%, the other is decreasing by 45%. Again, if this number right here was less than 1, then you would need to know this math and be able to figure out which of those is correct. In this particular problem, they've kind of done the work for you because that number being less than 1 means it's decreasing. That means it's increasing. D is out. C is my answer. Okay, number 24. The graph of y equals f of x plus 14 is shown. Which equation defines the function f? So this plus 14 means, because it's outside of the function, if you have a number that's being added on outside of the function, man, the SAT loves these kind of problems. They love numbers being added inside and outside. So actually, I'm going to do a quick little aside here and just kind of show you the basic rule. If I have a function that's like an x squared, it's like f of x equals x squared. If I want to move this up, zoom out and move over. Let's say I wanted to move it up 2. The way you do that, the way you make it so that this thing moves up 2, it doesn't change any other way, you add 2 on the outside of that. If you wanted it to go down 2, want it to go down 2 but stay otherwise the same, you subtract 2. If you want it to move left and right, it needs to be inside here with the x. And it's the opposite. So for instance, if it's to the right 3, it needs to be opposite of it and needs to be in there with that x. If you want it to move to the left 4, so that is moving towards the negative, so that's a negative 4, you put the opposite, x plus 4 squared. If you wanted to move, let's see, go back. Let's say you want to move to the right 3 and up 2, x minus 3 squared plus 2. You can combine them. They love this kind of thing. They love it. They love it. They love it. If you have a number out here out front, if it is a number greater than 1, in this case, it's going to change the slant, the slope, the for a parabola, it's going to change how narrow or wide it is. It's that kind of thing. It transforms it that way. It doesn't move it. It's like, say, if this was a 2 out here, a number greater than 1, it's going to become more narrow. If it's a number less than 1, like 1/2, it's going to become wider. Man, the SAT, they love these kind of problems where they're asking you to move things around on the board. And that's what this one is. That's what it is. So we have this f of x, and it's just a line, is shown which equation defines the function. Now let's look at our answers. You'll notice they're all in y equals mx plus b format. And when things are in y equals mx plus b, m and b are just numbers or constants. M is our slope. B is our y-intercept, where it crosses the y-axis. All of these have the same slope. So I don't have to worry about figuring out what the slope of this line is. I just don't. They all do, however, have different y-intercepts. So currently, this previous line was taken and then 14 was added. And we've just said, if you have that number added to the outside of it, not in there with the x, just add on the outside, that number moves it up or down depending if it is positive or negative. This one we have a positive 14, so this line was moved up 14 to end up at 2. So to find out where it originally was before that 14 was added, we need to go down 14 from 2. 2 minus 14 is negative 12. So let's look for the one with negative 12 as my intercept. There it is. A is my answer. 25. RS equals 20, ST equals 48, and TR equals 52. The side lengths of a right triangle RST are given. Okay, before I go further, I'm going to draw RST. All right, so a right triangle. The RS, that's our little short side. ST is our longer side, and our longest side, our hypotenuse, is TR. Okay, so RST. There we go. Got it. Got a right triangle. Triangle RST is similar to triangle UVW. Now they go a little bit further and say S corresponds to V and T. Okay. But honestly, if they tell you RST is similar to UVW, that means the first corresponds to the first, the second to the second, the third to the third. That's the standard way that it's written. So RST, UVW, it could be bigger, it could be smaller, it could be the same. We don't know. I'm going to draw it smaller. I'm going to call it U. Let's move it down a little bit. U, V, W. And actually, I'm going to also write on RST our lengths because we had 20, we had 48, and we had 52. And so they're both right triangles. Okay. What is the value of the tangent of W, the tangent of this? Similar triangles all have the same angles. Their corresponding angles are the same. So whatever measure angle R is, it's going to be the same as U. Whatever T is, it's going to be the same as W. Now the tangent, or any of the trigonometric things, sine, cosine, or tangent, they're always the same for the same angles. So the tangent of 45 degrees is always the same no matter what triangle it's in. And how do you find tangent? It is the opposite over adjacent. Okay, so for this angle, the opposite side is the side, not the hypotenuse. The hypotenuse is not involved in tangent. It's the two short legs. The opposite side is the one that it is looking at, not the one that's next to it. The one that's next to it or touching it is adjacent. If you have a hard time remembering that, think of like if you're sitting at a dinner table and I'm looking at aerial view, like say I'm sitting here, who is opposite me? I'm looking at him. Who's adjacent to me? I can bump him with my elbow. So there's our opposite and adjacent sides. So the tangent of T here is opposite over adjacent, 20 over 48. W and T are the same. Those angles are the same degree. So W is also 20 over 48. It doesn't matter that these are likely different lengths. This fraction, this ratio is what we're interested in. It's going to be the same. But this has not been simplified. 20 over 48, they're both divisible by 4. So let's simplify this fraction. 20 divided by 4 gives me 5. 48 divided by 4 gives me 12. So 5/12 is the ratio of opposite to adjacent side for this angle. And it's going to be the same for T and W. So I'm looking for 5/12. There it is. B. That is my answer. 1 gallon of paint will cover 220 square feet of a surface. A room has a total wall area of W square feet. Which equation represents the total amount of paint P in gallons needed to paint the walls of the room twice? Okay, so I know 1 gallon is 220 square feet. All right, writing that down. A room has a total wall area of W square feet. Let's pretend for a second that W is equal to, let's say, 400 square feet for this wall. It's a very tiny room. It's a little room, 10 by 10. And so okay. So 10 by 10 room, 10 feet high ceilings, 400 square feet. All right. How would I figure out how many gallons of paint I would need? I would say, okay, 220 square feet per gallon. Let's divide 400 by 220 to see how many gallons I need. Okay, so there my W is on top, my square feet are on the bottom, and I would divide that. I would figure out how many gallons that I need. Okay, so we've got our relationship. We would have the total area of square feet that we need to paint on top. We would have the amount per gallon on the bottom, and that would give us how many gallons of paint. That was the process that we would use for this. So we're going to keep that in mind, even though we're going to be working with variables and not this just straight number. They haven't told us the number. We've just said it's just W. So which equation represents the total amount of paint P in gallons? Okay, so they don't want us to use G. They want us to call it P. How many gallons of paint? So total amount of paint P in gallons needed to paint the walls of the room twice. So let's think of that when we had our number. If that was 400 square feet in the room, how many would it be? Would we be painting if we painted it twice? It would be that 400 times 2, right? Or 800 square feet. So we would take that square footage and multiply by 2. So that's what we're going to do. Okay, so that's with a real number. Now here's with just the W representing that number, whatever it is. In our example, it was 400, but it's just called W. It's an unknown number. We're painting it twice. We multiply by 2. Same difference, even though it's a variable, it behaves like a number. So we'd multiply by 2. Okay, now do we see 2W over 220 anywhere over here? No, we don't. And that's because 220 is divisible by 2. So this fraction can be simplified. We can take this 2 out of both of them. So we can divide the top by 2, and that just leaves W. We can divide the bottom by 2, and that leaves 110. So my final equation is P equals W over 110, and that is A. All right, last one. You made it to the end. Number 27. The number A is 110% greater than the number B. The number B is 90% less than 47. What is the value of A? Let's write some equations for this. The number A is. When you see that is, the vast majority of the time, I can't think of an exception offhand, it means equals. So the number A is 110% greater than the number B. Okay? So it is B, and it's 110% greater. So it's B plus 110% of B. So we represent that 110% is the same as 1.10 or 1.1. So it's 1.1 times B. So that's what A is. Now I know B is 90% less than 47. Something that's 90% less than is the same as saying it is 10% of it. So, like, for example, if you said 10 is 90% less than 100, they took 90% of 100 away and you got 10. Another way, again, like I said, or you can say 10 is 10% of 100. So we're going to use that fact and say, okay, 90% less than 47 or 10% of 47. So 10% of 47. Okay, we can start doing this math. I want to find out what b is, and there are no variables in this second equation, so I can solve for b. B is equal to 0.1 times 47, or 4.7. Now that I know b is 4.7, I can take it and plug it in to those two. So first one, b here, that's going to be 4.7. And then over here we have 1.1 times 4.7. And this is the point, if you'd like to use your calculators, go for it. And you get that A is equal to 9.87. And another little side note, this little bit right up here where I plugged it in for B, if you wanted to, and I'm going to just back it up a second, what you absolutely can do at this point right here, you can combine those before you put the 4.7 in. It doesn't matter. Either way is fine. Whatever's fastest and makes the most sense to you. So yes, if anyone's out there going like, why didn't you just combine them? You can. I actually did when I was, I always take the test first myself as a practice, before I explain it to everyone. And yeah, when I was doing it, I actually combined that and said, oh, that's 2.1b. And then I plugged 4.7 in there. It works either way. You get the same answer. Doesn't matter. A is equal to 9.87, and that is your answer. And you made it at the end. Congratulations. Be sure to check out my math-related merch on Spreadshop or Etsy, links down below. And if you found this helpful or useful in any way, please help me help others. Like, share, comment, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.